So, hello everyone, welcome to the second video of AWS CCP exam certification. So, in first video we have already covered domain 1 and domain 2, and in this video we will start with domain 3. So, if in case you have not watched domain 1, I would suggest you to go through domain 1 and 2, that part 1 video first, and then come back to this domain 3 video. So as told in part 1, I have recently given AWS CCP exam, and I have passed with 882 marks, and I have referred the same notes that I am currently uh, referring. So let me quickly start with domain 3. Domain 3, I missed domain 3. And I will also recommend to go through the official syllabus of AWS, so that if in case of any updates you will be uh, referring to make sure you will be referring to the updated syllabus. So that's why, yeah, domain 3 technology. So it is most important domain as it is covering 36% of the examination. So these lines, as I already told in the part 1, I have copy pasted these lines from the syllabus itself. So define methods of deploying and operating in AWS cloud. So how can user access AWS? So there are three ways with the help of which we can access AWS. So first one, AWS management console, which is protected by password and multi-factor authentication. So it's nothing but a device, hardware device, where we will get a code, and that code we will need to put while logging in along with our password, just to ensure security. Then the second option is AWS CLI, which is nothing but command line interface. So it is protected by access keys and AWS SDKs. So it is also protected by access keys. Access keys are nothing but username, access key ID, and the secret access key, which is nothing but equivalent to password, username and password. So first, let's see CLI, command line interface. So command line interface is nothing but a tool that enables us to interact with AWS services using commands in the command shell. So if somebody is familiar with commands and more comfortable with commands, then he can use CLI to manage AWS services. So we can have direct access to public APIs using CLI. We can also develop scripts to manage our resources, and it is open source. The next is AWS SDK, software development kit. So it is language specific. It has language specific APIs, and it enables us to access and manage AWS services programmatically. So it supports SDKs like JavaScript, Python, PHP, .NET, Ruby, Java, Go, Node.js, and C++. Uh, then mobile SDKs as well, Android, iOS, and IoT devices. So one of the examples is AWS CLI is built on AWS SDK for Python. So that's about CLI and SDK. So not that much important, but we can have read and take a look. The next one we have is AWS Cloud Formation. So this is one of the AWS services and important service as well. So it is used to outline your AWS infrastructure. So while creating AWS infrastructure, let's say we can with the help of cloud formation, we can say that I want one security group, I want two EC2 instances, one S3 bucket, and an elastic load balancer. So just to simplify, we can use cloud formation. So we'll be having one template which can be reusable. So if we talk about benefits of AWS cloud formation, so this is infrastructure as a code, right? No resources are manually created. So we will be having a template with the help of which we will create resources. So we don't need to specify all the details manually, and we can reuse the template as well. So talking about cost, so we can estimate the cost of resources using cloud formation template. So once we have the template, then we know that how many security groups, how many EC2 instances, how many S3 buckets we are going to need, and with the help of that we can estimate the cost. So next point is it supports almost all AWS resources, and we can use custom resources as well for the resources that are not supported. The next comes is cloud development kit. So now with the help of this service, AWS CDK, we can we can define our cloud infrastructure using a familiar language like JavaScript, Python, Java, .NET. So what happens is this code is will get compiled into cloud formation template, JSON or YML, and so this service is great for Lambda functions and Docker containers in ECS and EKS. So ECS is nothing but Elastic Container Service, and EKS is Elastic Kubernetes Services. So that's about Cloud Development Kit. The next service that we have is AWS Elastic Beanstalk. Now Beanstalk is helpful to deploy and scale web applications and services automatically. So this one line is enough. You'll find questions on this line itself if in case there is a question on Beanstalk. The next is code commit. So a famous public offering is GitHub. So we all know that GitHub is a famous public offering which is used to manage code repositories. So AWS has the competing product known as code commit, so which offers same features as GitHub. The next we have is code build, which is also platform as a service, and it compiles source code, run tests, and produces packages that are ready to be deployed by code deploy. So code deploy is next service which is used to deploy and our application automatically. Now code deploy is hybrid service, so it can work with EC2 instances and on-premises servers as well. The core deploy agent is there, so which is used to provision servers and instances. So that's about core deploy. Now next service is core pipeline, which is platform as a service again, and it is used to orchestrate the different steps to have code automatically pushed to production. So it is nothing but basis for CI/CD, continuous integration and continuous delivery. The next we have is AWS Code Artifact. Now code artifact is nothing but software packages that depend on each other to be built. We also know code dependencies in Java, if you know. So and the new ones that are created. So new ones means the dependencies that are created. So to store retrieve these dependencies, we use code artifact, and so this is nothing but artifact management. You can shortly remember that code artifact is used for artifact management. Now code artifact is secure, scalable, cost effective artifact management for software development. So it works with common dependency management tools like Maven is there, then Gradle is there, npm is there, Yarn is there, Twine, Peep, and NuGet is there. Now developers and code build can retrieve this dependency straight from code artifact. So this is about code artifact. I have not seen much questions on code artifact or this code commit, code build, code deploy, but it's simple and easy to remember as well. So added few lines for all these services. Now the code star is there. So code star is nothing but this is unified UI. to easily manage software development activities at one place. So we can quickly get started with code commit, code pipeline, code build, code deploy, elastic beanstalk, EC2, etc. And we can also edit code in the cloud using AWS Cloud 9. Cloud 9 is the IDE basically, uh, like IntelliJ IDE. So AWS Cloud 9, as I told, it's an IDE. So for writing, running, and debugging the code. So at the same time, members of the team can work on the same project, and uh, with the help of this AWS Cloud 9. The next we have is Systems Manager. So AWS Systems Manager is also a hybrid service which is used to get operational insights of the resources. So these highlighted words are important. Why this service is used. So most important features of this AWS Systems Manager is patching automation for enhanced compliance, run commands across an entire fleet of servers. So hundreds and thousands of servers. So we can run command at the same time on the entire fleet of servers. We can store parameter configuration with the SSM parameter store. So that's pretty much about the SSM. The next we have is SSM Session Manager. So we use this Session Manager to start a secure shell on your EC2 and on-premises servers. So key important point about SSM Session Manager is no SSH access is required, no bash and host is required, or no SSH keys are needed to SSH into the EC2. No port 22 needed. So it supports Linux, macOS, and Windows, and it sends session log to S3 or CloudWatch logs. So that's about SSM Session Manager. So about SSM Manager, mostly I have seen questions like which service we use if in case we want to SSH into EC2 without port 22 access or without SSH access. Like these questions will be there. So next is operational works, ops works. So this service is nothing but shape and puppet which help you perform server configuration automatically, and it's an alternative to AWS SSM. Okay, so that's about 3.1. Now 3.2 from the syllabus is define AWS global infrastructure. So as a part of global infrastructure, we have region, availability zone, and edge location. So I have not written details for each of these, like what is region, what is availability zone, and what is edge location. I have just written important points. So just to give you an idea, so region has multiple availability zones basically, and edge locations are part of. I mean, all these are part of global infrastructure only. But edge location is something different. So each region has minimum of 3 availability zones. So that's important point to remember. Then as a part of global infrastructure, we have AWS Global Accelerator. So by accessing an application through edge location, so this is the short way of remembering what is the purpose of AWS Global Accelerator. So here I have written, so let's say if we have an application hosted in India and somebody from America wants to access it, then the user can access this through the nearest edge location. So this way we will leverage the AWS internal network to optimize the route to your application. So what we are doing, we are accessing the application but through edge location. So this way uh, it will be quick access. So that's about global accelerator. Then the similar way we have CloudFront, which is nothing but content delivery network. So difference here is we are accessing through edge location only, but the difference here is here we are catching the content at edge location, so it improves read performance. So somebody, let's say from America, wants to access content. So what whichever is the nearest edge location, there the content will get captured, and this way uh, it will be quick to read. So it will improve read performance. So we also have DDoS protection for this CDN, and it is integrated with Shield and WAF as well, Web Application Firewall. The next is S3 transfer acceleration. So what is this? This is nothing but we transfer files to edge location first, and then we transfer to the our targeted location. So this also uh, leverage the edge location concept. So it increases speed transfer, speed by transferring the file to AWS edge location, and then from edge location to the S3 bucket in the target region. So this way we are with the help of edge location, uh, we are getting the files transferred quickly. Okay. The next we have is AWS Outpost. So AWS outposts are nothing but server racks that offer the same AWS infrastructure, service, APIs, and tools to build your own application on premises, just as in the cloud. So AWS will set up and manage outpost racks within your on-premises infrastructure, and you can start leveraging the AWS services on premises. So server racks, you can remember, it is very self-explanatory. Then we have wavelength. So a wavelength is nothing but there are wavelength zones, and which are nothing but infrastructure deployments embedded within the telecommunication providers data centers at the edge of 5G networks. This provides ultra low latency applications through 5G network, and traffic doesn't leave the communication service providers network. So these are some points, not so important but better to take a look. So high bandwidth and secure connection to the parent AWS region. So if we talk about use cases, then smart cities, ML assisted diagnostics, connected vehicles, interactive live video streams, AR, VR, and real-time gaming, etc. The similar way we have local zones, like as we have wavelengths, similar way we have local zones. So in case of local zones, what we do, we place AWS compute, storage, database, and other selected AWS services closer to the end users. Okay, so it will be placed closer to the end user, so that's why we are calling local zones. So this will be very useful to run latency sensitive applications. So this is highlighted. That means I have seen one question on this, like which of the below services are useful to run latency sensitive applications. So the correct option will be AWS local zones. So these are global application architecture. So we can have single region single availability zone, then single region multi availability zone architecture, multi region active passive. So passive means it can read but not write, and multi region active active. The next we have 3.3 is AWS core services. So as a part of core services, we have compute services first. So EC2 compute service, so it is nothing but elastic compute cloud. It is infrastructure as a service. So it mainly consists of below capabilities. So with the help of EC2 service, we can rent virtual machines, store data on virtual machines using EBS, then distribute load across the virtual machines using elastic load balancing. Then we can scale services using auto scaling group. The next we have is sizing and configuration option for EC2. Not so important, but yeah, I mean better to read. So this is important, highlighted ones. So as a part of OS, we have Windows, Linux, and Mac OS. And as a part of storage, we can choose network attached storage uh, with the help of Elastic Block Storage Service and Elastic File Storage Service. These services we will see afterwards. Now, hardware, as a part of hardware storage, we can have EC2 instance store. And the next is EC2 user data script runs with the root user. So in order to run EC2 user data scripts, we should use root user access. The next service we have is Amazon Machine Image. So Amazon Machine Image is nothing but customization of an EC2 instance. So we can add our own software configuration, OS, and monitoring. So the benefit that we get is faster boot configuration time because of the all the softwares will be pre-packaged. Now AMI is built for a specific region. So that means while creating an AMI, we need to specify region, and it can be copied across regions, but it is built for a specific region, even though we can copy across regions. The next we have is EC2 image builder. So EC2 image builder is used to automate the creation of virtual machines or container images, and automate the creation, maintenance, validation, and testing of EC2 AMIs. So there is a difference between AMI and EC2 image builder. So because the same question I got in my exam, and I got confused between AMI and EC2 image builder. So that's there, and it is a free service. We need to only pay for underlying resources. So next service we have as a part of AWS compute services, it's AWS Lambda. So how Lambda is different from EC2. So EC2 is nothing but virtual server in the cloud, but Lambda is virtual functions, no servers to manage. AWS takes care of the servers. Now EC2 is limited by RAM and CPU, but Lambda is limited by time, right? Short executions will be there. EC2 is continuously running, but Lambda we can run on demand. And for scaling, in case of EC2, we need to intervene to add and remove servers. But in case of Lambda, it is automated because AWS takes care of the servers. Now, if you talk about benefits of Lambda, easy pricing, then integrated with whole AWS services, event driven. So if in case we want any Lambda function to be executed after any event, then that could be done. It is integrated with many programming languages, easy monitoring through AWS CloudWatch, and easy to get more resources per function. The next we have is Elastic Container Services. So it is used to launch Docker containers on AWS, and it is not serverless. And EKS, Elastic Kubernetes Services, so it is used to run Kubernetes on AWS. Kubernetes is nothing but open source software that enables you to deploy and manage containerized applications. The next is Fargate, which is platform as a service, and it is also used to launch Docker containers on AWS, but it is serverless. So the main key difference between ECS and Fargate is the one is not serverless, but the another is. So AWS Fargate is serverless compute engine for containers, and it works with both ECS and EKS. So when using Fargate, we do not need to provision or manage servers, as it is serverless. So AWS takes care of the servers. Now next is Elastic Container Registry. So it is nothing but private Docker registry. This is used to store Docker images so that they can be run by ECS or Fargate. The next one is Batch. So Batch is platform as a service, and it is used to manage required EC2 instances. So it is fully managed batch processing at any scale. Batch will dynamically launch EC2 instances or spot instances. So if in case you don't know spot instance or EC2 instance we have seen, but spot instances we will see in further. So you submit or schedule batch jobs, and AWS batch does the rest. So batch jobs are defined as Docker images and run on ECS. So that's about batch. So talking about the difference between batch and lambda. So lambda has a time limit, but batch doesn't have a time limit. Lambda has limited run times, whereas batch can run for any time if it's packaged as a Docker image. Lambda has limited temporary disk space, whereas batch relies on EBS instance store for a disk space. Lambda is serverless, whereas batch relies on EC2 and can be managed by AWS. So these are not that important points, but better to take a look. The next is Amazon API gateway. So this is platform as a service, and it is useful for developers to easily create, publish, maintain, monitor, and secure APIs. It is serverless and scalable, and it supports RESTful API and WebSocket APIs. It supports support for security, user authentication, API throttling, API keys monitoring, etc. So the next we have is Amazon Lightsail. So Lightsail is nothing but virtual server, storage, databases, networking, same like AWS, but it has some limitations like no auto scaling, limited by AWS integrations. So you can say it is same like AWS only. It offers same AWS services, but it's just some limitations will be there. And just to get started, if you are new, then you can go with the Amazon Lightsail first before directly uh, getting started with the AWS. So that's about Lightsail. Then elastic load balancing and auto scaling group, these are very important services. You'll definitely going to see questions on this. So talking first about elastic load balancing. So load balancers are the servers that forward internet traffic to multiple servers. So as the name itself suggesting, load balancing. So load balancer exposes single point of access to your application. It also does regular health checks to your instance and provide SSL termination. So along with this, we also need to remember a few other points as well, because uh, the name suggesting load balancing means we think that it is only used to forward internet traffic to multiple servers, but along with this, it also does regular checks, and it also provides SSL termination. So it is managed service. And type of load balancers, if we see which are offered by AWS. So we have application load balancer and network load balancer. Now next we have auto scaling group. So talking about auto scaling group, we can scale out, that is add instances to match increased demand. We can scale in, remove EC2 instances to match decreased load. Then we can ensure to have a minimum and maximum number of machines running. So we can say that in any case I want minimum of 2 and maximum of 5 machines running, so that we can specify. Then we can automatically register new instances to load balancer, and we can also, so this can also automatically replace unhealthy instances. So uh, it is auto scaling group is also taking care of health of the EC2 instances. And in case of elastic load balancing as well, we have seen that regular health checks are there. So that's about it. And if we talk about scaling strategies, so I have seen only one question, that too in one of the practice exams. So not so important, but yeah, there are some scaling strategies. First is the manual scaling. So update the size of ASG manually, right? We manually need to do this. Then in dynamic scaling, we have simple step scaling. So let's say when a CloudWatch alarm is triggered, example CPU greater than 70%, then add 2 units. Then target tracking scaling, where we can say that average auto scaling group CPU we want to stay around 40%. Then schedule scaling, so we want to increase minimum capacity to 10 at 5 p.m. on Fridays. And the predictive scaling, so let's say if you This uses actually machine learning. This is something different. So this uses machine learning to predict the future traffic ahead of the time. So this is something different. So that's about the scaling strategies. The next important is the storage services. So it is also very important. So talking about the use cases of Amazon S3. So let's start with S3, Amazon S3. So simple storage service SSS. So that's why S3. So talking about the use cases, archiving, application hosting, backup, cloud storage, disaster recovery. Then direct questions I have seen on this, media hosting. To host a static website we use S3. Then data lake, big data analytics, software delivery. Okay. And then we have buckets. So S3 allows people to store objects which are nothing but files in buckets which are nothing but directories. Buckets should have a global unique name, and buckets are defined at the region level. So these two are important points. S3 look like a global service, but buckets are created in a region. So you may think that buckets are globally created, but these are defined at region level. So there is a region associated with the bucket. Um, so Amazon S3 security. So there are securities based on user resource. So talking about user-based security, then IAM policies we can use. So which API calls should be allowed or and which are not, that we can specify with the help of IAM. Then resource-based, if we see, then we have bucket policies. So bucket-wise rules will be there. Then object ACLs will be there and bucket ACLs will be there. Next, so there is this note which is saying that an IAM principal can access S3 object. So we have already seen in the last view that what is principal. So principal is nothing but the account, user or role. So IAM principal can access S3 object if user IAM permission allows it or resource policy allows it, and there should not be explicit deny. Okay, so that's about this. We can encrypt objects in S3 using encryption keys. And S3 bucket policy we can use to grant public access to the bucket, force objects to be encrypted at upload, and grant access to another account. So talking about replication strategies, we have cross-region replication, same region replication, and buckets can be in different AWS accounts. So this is one point. And copying is asynchronous. So that's about the replication strategies. And so S3 storage classes. So if we talk about S3 storage class, we have S3 standard, which is further divided as general purpose and infrequent access. So general purpose is used for frequently accessed data. So cost will be less compared to, sorry, cost will be higher as compared to other storage classes. But if in case we need to store data that is frequently accessed, then this general purpose is recommended. It sustains two concurrent facility failures. So that means one availability zone goes down, we have second, and second availability zone goes down, then we have one backup. So it can sustain two facility failures. So S3 standard infrequent access. So if in case the data is in less frequently accessed but requires rapid access when needed, so in such scenarios like disaster recovery, backup, we can use infrequent access tier. Now the third one is the one zone, infrequent access one zone. Now one zone, the name itself says that one availability zone only. So if that availability zone is destroyed, then your data is lost. So that's why use cases for this is like secondary backups and thumbnails. The last one, not last, the next one is Glacier Storage class. So Glacier Storage class, the name itself suggests that we are storing data for longer time. Glacier. Now low cost object storage we can do with the help of these Glacier storage classes. So for archiving or backup, then data encryption is automatically enabled. So data encryption is automatically enabled. This is one important point for Glacier storage classes, and this Glacier storage classes is meant for archiving and backup. Now we have Glacier instant retrieval, flexible retrieval, deep archive. So these three types. So first, instant retrieval, we can retrieve in seconds, but minimum storage is 90 days. And in case of flexible retrieval, we can retrieve in minutes, but the storage is 90 days. And for deep archive, it is used for long-term storage. So retrieve will need hours, and minimum storage is 180 days. So next is intelligent tiering. This is important. So what it does basically is it moves objects automatically between access tiers based on the our usage. So default tier is S3 standard, and if in case we don't access any objects for 30 days, then it will get moved to S3 standard. IA means infrequent access. Then let us say we don't access any object for 90 days, then it will move to archive instant access tier, and we can configure as well as per our need. So but there are no retrieval charges, but only intelligent tiering fee for this service. Now next we have is EBS, Elastic Block Store. So Elastic Block Store is used to provide root storage volumes to EC2 instances, as we have seen earlier in the EC2. EBS delete on termination attribute is there. So by the default, this attribute is enabled, which means the root EBS volume is deleted, and by default any other attached EBS volume is not deleted. Okay, so that is there. So if in case you want to preserve the root EBS volumes, you need to disable this attribute, and then your EBS volume will be preserved. You need to explicitly delete that. So that's about this attribute. Then EBS snapshot. So make a backup which is nothing but a snapshot of your EBS volume at point in time. So we can take a snapshot, and we don't necessarily need to detach volume to do a snapshot, but it is recommended. So we can copy snapshot across availability zone or region. So that's all about EBS. Talking about EFS, Elastic File System. So it is managed network file system that can be mounted on multiple EC2 instances. Now EFS works with Linux EC2 instance in multi-availability zones. So in case of Linux EC2 instances, we can work in multi-availability zones, but not for others. So just to see the key difference between EBS and EFS. So EBS is availability zone bounded, but EFS is not availability zone bounded. I have seen several questions on this during practice exam as well, and I think in main exam as well I saw question on this. I came across question on this, so this is important point. So talking about elastic file storage infrequent access tier. So storage class that is cost optimized for the files that are not accessed every day. So with the help of this, we will get up to 90% lower cost compared to EFS standard. As compared to this EFS standard tier, we will get 90% lower cost, and EFS will automatically move our files to EFSI based on the when they were last accessed. So to enable this, we have lifecycle policy. So let's say in lifecycle policy we can mention that move files that are not accessed for 60 days to EFSI. The next that we have is instance store. So EBS volumes are network drives with good but limited performance. So if we need high performance hardware disk, we can go ahead with the EC2 instance store as a EBS, EFS and S3 can't be uses hardware disks, right? So these EBS, EFS, S3 can't be used as a hardware disk, so we can go ahead with the instance store. Now EC2 instance store loses their storage if they are stopped. This is one disadvantage of EC2 instance store, but it provides high performance. The next that we have is AWS Snowcone. So it is nothing but a small portable computing anywhere, rugged and secure, withstand harsh environments. So it is nothing but a device. Just search these devices on Google. Snowwheel, snowball, edge, snow cone. So you will when you are going to see the picture, then it will be more clear to you. So this is nothing but a device which is used for edge computing, storage and data transfer. So we can use this for 8 TBs of usable storage. Then we can use snow cone where snowball doesn't fit, where space constrained environments are there, we can use snow cone. So we need to provide our own battery and cable. So this is not that important point, no one is going to ask, but I have added. And we can send this back to AWS offline or connect it to the internet to using AWS data sinks to send data that we have collected using Snowcone. Talking about Snowball Edge, it natively supports Amazon EC2 and it is a physical data transport solution to move terabytes and petabytes of data. So it is alternative to move data over network as well. So if in case it is feasible for you to uh, use this Snowball Edge for data transfer rather than paying network fees, then you can use this option as well if it is economically feasible. So we need to pay per data transfer job, and it provides block storage and Amazon S3 compatible object storage. So that's pretty much about Snowball Edge. And the next one is the Snowmobile. So if we need to transfer more than 10 petabytes of data, then we can use Snowmobile. So to transfer exabytes of data basically. So each snowmobile has 100 petabyte of capacity. So it is high security. So it is temperature controlled. GPS is enabled. 24/7 video surveillance will be there. So and talking about operational hub, so Ops Hub, it can be installed on a computer to manage Snow family devices. The next one is AWS Storage Gateway. It is hybrid storage service to allow on-premises to seamlessly use AWS cloud, and data encryption is automatically enabled. So for this as well, data encryption is automatically enabled, and earlier we saw for Glacier service it was automatically enabled. So far we have came across two services. So um, the next is FSX. So FSX is nothing but third party high performance for file system on AWS. So you to use uh, or to launch third party high performance file system on AWS, we can use FSX. It supports SMB protocol and Windows NTFS. It can be integrated with Active Directory and can be accessed from AWS or on-premises infrastructure. The next one is the FSX for Lustre. So it is nothing but a fully managed high performance scalable file storage for high performance computing. And as the name suggests, Lustre, so it is derived from Linux and cluster. So Linux clusters means a Lustre. So machine learning, analytics, video processing, financial modeling. So these are some use cases for Amazon FSX for Lustre. So that's all for I think this part 2 will cover from AWS database services in the next part. So it will be part 3. So uh, that's about it. Today we have I think 12 more pages to cover all these notes. So let's see. I will try to finish it in part 3. If not, then there will be 4 parts for this AWS CCP. So thank you everyone. Have a good day.